Good morning to everyone.
Good morning, sir.
Good morning. Okay, so yesterday I gave 3 problems as a practice problem. I think the first problem is, please check it whether I gave this problem. Show that the vectors x1 equal to 2, 2 minus 2, 1, and x2 equal to 1, 4 minus 1, and x3 equal to 4, 3, 4, 6 minus 3 are linearly independent. So how you tried? Everybody tried this problem? If you got the answer, you can tell. So how you approach? Okay.
Using the third method, sir.
Using
Yes, sir, tried this problem.
okay. First, Uddaman, please tell. Using third method means which method?
Sir, converting this as a matrix and then taking the determinant. If the determinant is not equal to 0, then they are linearly independent.
You got it. Determinant not equal to 0. Uddaman.
Yes, sir. Minus 20, sir.
Minus 23. Okay. What about
Minus
Paritosh?
20, sir, not 23, sir.
Minus 20.
Yes, sir.
Sir, I tried with the second method, row echelon form.
Row echelon form. Okay.
Yes,
Okay.
sir. So after converting into the echelon form, the number of non-zero rows is equal to the number of vectors. So all the three are linearly independent.
Yes. Yes. Correct. Anybody tried the first method? Okay. So then I will do by first method. Solution, method 1. So if you want to do by method 2, method 3, you can try later. So method 1, first you should assume what? K1, x1 plus K2, x2 plus K3, x3 is equal to 0. So if it is linearly independent, means I need to prove all the Ki's, K1, K2, K3 are equal to 0. So K1 into x1. What is x1? 2 minus 2, 1 plus K2 into x2 is of 1, 4 minus 1 plus K3 into x3, 4, 6 minus 3 equal to, this is 0, 0, 0. So directly I will write the equation. So please check it. 2K1 plus K2 plus 4K3 equal to 0. Second equation, minus 2K1 plus 4K2 plus 6K3 equal to 0, plus K1 minus K2 plus minus 3K3 equal to 0. So 1, 2, 3. So 1 plus 2. If you add 1 and 2, you will get what? So K1 is eliminated. We'll get 5K2.
2 is equal to minus 2K3.
5K2 plus 10K3 equal to 0. If you divide by throughout by 2, you'll get what? K2 plus 2K3 equal to 0. So this is equation 4. Okay. And from 2 and 3, okay, well, if you multiply the second equation by 2, third equation by 2, okay, multiply third equation by 2 and add with equation 2. Okay, well, so if I multiply third equation by 2, you'll get what? 2k1 minus 2k1, 0. Okay, va? Similarly, minus 2k2 plus 4k2, you'll get a 2k2. Okay, and then minus 6k3 plus 6k3 gets cancelled. You'll get a 2k2 equal to 0. This implies k2 equal to 0. If k2 equal to 0 implies equation 4 implies k3 is 0. If k2 and k3 is 0 implies if you substitute any one of the equation 1, 2, 3, you'll get k1 is 0. So therefore the vectors x1, x2, x3 are linearly independent. Linearly independent. Okay. So at the second problem, I think I gave this is a second problem. So how you tried? Anybody got the answer? Show that the vectors actually. Okay, I think this is not that much difficult. Okay, only thing you need to try. Suppose if you tried, if you don't get it, okay. Show that the vectors x1, x2 and x3 are linearly independent. So the matrix A is what? 1, minus 1, minus 1, 3, 2, 1, minus 2, minus 1, 7, 2, minus 7, 4. Okay. So, okay, at least now you can tell the answer. Okay. So now I am going to convert into row echelon form. So please tell the transformation.
R2 is equal.
Yeah, please tell.
R2 is equal to.
First R2. First start from R2.
R2 is equal to R2 minus 2R1.
R2 minus 2R1. Okay, first I
R2
will,
is
1 minus 1 minus 1, 3. So you will get what? 0, 0. Here, what is the second element here? R2 or 3,
3 0 minus
3, 0.
Minus 7.
Minus 7. Yes, correct. And then what is the one more operation, transformation? In place of R3 minus
7R1.
7R1. 0. 7 means minus 7 means
9.
plus 7, 9.
0
Plus
17.
7, 0. Yes, 0. This is minus 20.
17.
Minus 17. Yes. Okay. So now I need to convert this position is 0 using this diagonal element. So you need to multiply.
Sir, R2 zeros, R2 dash.
Okay. Here I am not going to write. Actually, you are correct, Kavimani, yeah.
Yes, sir.
Yeah, you are correct. But why I am putting R2 dash yesterday? Actually, I want to express each vector as a linear combination of the other. So for this, I need some other notation. But here I don't. The problem just linearly independent. So that's why I'll keep R2. Okay.
Okay, sir.
Yeah. Even if you write by R2 dash, it is not a problem. Okay. Now, this is equivalent to I need one more operation. Okay, first two rows. Please tell 1 minus 1, 1 minus 1, minus 1, 3. Yeah.
3,
Second row.
0, 3, 0 minus 7.
0, 3, 0 minus 7.
Yes, sir.
Minus 7. Third transformation. What is the third transformation?
R3 implies R3 minus 3 R2.
R3 minus 3
Minus
R.
3 R2.
Yeah. So you have already 0, 0, 0, 0. And the last one is what? Minus 21, minus, minus 3 plus 21. So 4.
4.
Yeah, 4. So that's all. Okay. So the number of non-zero rows in the echelon form of A is 3, and the number of given vectors also 3, and hence the vectors are linearly independent. In the echelon form, A is equal to number of given vectors is equal to 3. Okay. So therefore, x1, x2, x3 are linearly independent. Okay. I think last column, I think I also gave this column, but I don't find also the relationship among them in the last class. So first I need to show that the vectors are linearly dependent. Okay. Okay, that is the first part. First I will do that one. The matrix A.
Sir, x1 plus x2 plus x3 is equal to x4. Sir.
You are using the definition of the one.
No, sir, that is the final answer, sir.
Final answer. What is the final answer? Please tell. X1.
x1 plus x2 plus x3 is equal to x4, sir.
Yeah, correct. The answer is correct. Yes. So A equal to, what is the elements? First row 1, minus 1, minus 2, minus 4. Second row 2, 3, minus 1, minus 1, 3, 1, 3, minus 2. Okay, 6, 3, 0, minus 7. So first we'll use the transformation. First row keep as it is, 1, minus 1, minus 2, minus 4. So first it should tell the transformation in place of R2.
R2 dash
R2 implies R2 minus 2 R1.
minus
R2
2
minus 2 R1. Okay, next R3.
R3 dash becomes R3 minus
R2,
3R1.
yeah, dash. Yeah, because I need the relationship. So okay, so R3 minus
3R1.
3R1. Okay, and then
R4 dash
dash
becomes
R4 minus.
R4 minus 6R1.
Okay, I need the elements. First, second row. Please tell. Calculate and tell quickly.
0,
5.
5.
3.
7.
3.
7.
7.
7.
Yeah. And then 0.
0.
4.
Yes, sir. 4.
6.
9.
9.
9.
12.
10.
10. Yeah. And then 0.
9.
6 plus 3, 9.
12.
12. Yes, 12. And then
17.
24 minus
17.
17. Yes. Okay. So I got it. Okay. Next, I want to make these two elements are 0 using this diagonal element. Either you can multiply this by 5, this by 4. Okay. You can do it. Or otherwise, first you should divide this by 5. Okay. Make it, this is 1. Okay. And then you can do. That is up to you. You can do it in any method. So simplification is you can decide. Okay. So now I am going to divide by 5. Then what is the first row? 1 minus 1 minus 2 minus 4.
Minus 4.
Yeah, minus 2 minus 4.
0.
Yeah, please wait. What is the transformation? First you should tell in place of R2 double dash
R,
R2 dash by
is equal to 1 by 5.
5. Okay. And R3 double dash is same as R3 dash. There is no change. Similarly, R4 double dash is same as R4 dash. There is no change. Okay. So now please tell if you divide by 5, you'll get 0, 1.
3 by 5.
0, 1, 3 by 5.
7 by 5.
7 by 5. So
0,
0,
4,
4,
9,
9,
10.
10. Last row,
0, 9,
0, 9,
12, 17.
12, 17. Okay. And then next, okay, I'm going to convert these two elements as 0. Transformation, first two rows, 1, minus 1, minus 2, minus 4, 0, 1, 3 by 5, 7 by 5. So what is the transformation in place of R3 triple dash? R3 triple dash. So please tell R3 double dash minus 4 R2 double dash. Is it correct? So if you do like this, okay. Similarly, next R4 triple dash is equal to R4 double dash minus
R2 double dash.
R2 double dash. Only thing I need a second row and third row. So do it and calculate and tell correctly. 0, 0. I can say this is 0, 0. This is 0, 0. Only I need these 4 elements. 9 minus 12 by 5. So 45 or 33 by 5.
5, sir.
Yeah. Okay, and then 10 minus 28 by 5, 50. So 22
by 5.
5, yes. And here 12 minus 27 by 5. So 24 minus 3.
No, sir. 60 minus 27 by 5. So 33 by 5.
33 by 5, sir.
33 by 5. I think where I am doing the mistake. 9. Okay. So 12 then. 12 minus. Is it correct?
27 by 5.
Yeah, 27. Yeah, 27 by 5. So 60. Yeah. Okay. Okay. So 60 minus
33 by
27.
5, sir.
33 by 5. Okay. Thank you.
22 by 5.
22 by 5 here also. Okay.
Yes, sir.
Okay. Thank you. Now The last one is just very simple. R4 4 dash is equal to R4 triple dash minus R3 triple dash, because I need this element is 0. I need this element. So while converting this element 0, this is automatically 0. Okay. So this is equivalent to, the above matrix is equivalent to 1 minus 1 minus 2 minus 4. Second row 0 1 3 by 5 7 by 5, 0 1 3 by 5 7 by 5. Third row 0 0 33 by 5 22 by 5, 0 0 33 by 5 22 divided by 5. And the last row I am going to use the transformation R4 4 dash is equal to R4 triple dash minus
R3 triple dash.
R3 triple dash. So I think you'll get all of them are equal to 0. So number of non-zero vectors in the echelon form is 3. Okay. Number of non-zero vectors in echelon form of the matrix A equal to 3, but we know that number of vectors are what? Number of vectors are 4. The number of given vectors, okay? Number of vectors is equal to 4. So, and hence, therefore, the vectors x1, x2, x3, x4 are linearly independent. So linearly dependent. Linearly dependent. Okay, but they are asking also the relation. So R4 4 dash is equal to 0. I'll start from here. Okay.
Sir,
So
number of non-zero rows, number of non-zero vector
number of non-zero vectors. Okay. Number of non-zero vectors in the echelon form. Okay. Non-zero rows are. Okay. Number of non-zero rows in this echelon form is 3, and number of vectors, that is the given vector is 4.
zeros இருக்கீங்க சார்.
புரியல.
ரோஸ் பதிலா இப்ப zeros எழுதிட்டீங்க.
Sorry. Number of non-zero rows. Yeah. In the echelon form is the matrix A is 3. Yeah. Number of given vectors or number of vectors is equal to 4. Okay. Thank you, Kavini. So therefore, the vectors are linearly dependent. Okay. So now, yes. So from the last step, we know that R4 4 dash is equal to 0. Okay, this is 0, but you can write this is what? R4 triple dash minus R3 triple dash. Okay, so this is equal to what is R4 triple dash? Please tell. R4 double dash minus 9 R2 double dash. R4 double dash minus 9 R2 double dash minus R3 triple dash. What is R3 triple dash?
R3 double dash
R3 double dash.
minus 4R2 double dash.
Okay, thank you, Partosh. Okay, now simplify this one. Okay, I think double dash. I think that there is okay. This is equal to R4 double dash. Okay, minus R3 double dash. Here minus 9. Here plus 4. So minus 5 R2 double dash. Okay, what is R4 double dash? R4 double
R4
dash.
dash.
R4 dash.
4 dash.
Okay, R4 dash. Similarly, R3 double dash is
R3 dash.
R3 dash.
Yes. Minus 5 R2 double dash.
R2 dash by 5.
Yeah, R2 dash by 5. So 5 gets cancelled. So R4 dash minus R3 dash minus R2 dash. Now you should tell what is R4 dash in terms of R. R4.
R4 minus 6R1.
Okay. Minus R3 dash is
R3 minus 3R1.
minus 3R1, and then finally minus R2 dash.
R2 minus 2R1.
Yes. Okay, thank you, Paritosh. Now, if you simplify R4, how many R3? Minus R3. How many R2? Minus R2. How many R1?
Minus R1.
Minus R1. Okay. Thank you. Okay, now, okay, okay, so once you write this, then you can write the relation among x1 comma x2 comma x3 and x4 is x4 minus x3 minus x2 minus x1 is equal to 0. Okay, or you can multiply throughout by minus 1. Okay, we'll get x1 plus x2 plus x3 minus x4 equal to 0. Okay, please write. Okay. Okay, so what I told you, so throughout multiply by minus 1. Okay, or x1 plus x2 plus x3, okay, minus x4 is equal to 0. Okay. So please, actually this is a problem in Veerarajan book. I think I sent you day before yesterday, I think so. So please check. The answer is also, the solution is also in that book. Okay, you can verify your answer. Okay, show that the following set of vectors are linearly dependent and find their relationship in each other problem. So at least you can try out of 5, at minimum 2 problems you can try. Similarly, show that each of the following vectors are linearly independent. So from out of 4, you can try at least minimum 2 problems. So now suppose there is one more idea. Just I will tell you. You can try later. Okay. Suppose this problem, they are asking only show that the vectors are linearly dependent. They don't ask the relationship. Then after this step, I will use a determinant for this matrix. So how to find the determinant of 4 by 4 matrix? Okay, I am going to expand determinant not through by this row, but through this column, because here I have 0, 0, 0. Okay, so then just I roughly tell you determinant of this one is what? 1 into determinant of the 3 by 3 matrix. 5, 3, 7, 4, 9, 10, 9, 12, 17. So remaining everything is 0, because minus 0 into determinant of anything, and then plus 0 into determinant of anything, and then minus 0 into determinant of anything. Okay. So if you expand this determinant, okay, you will get 0. You can check it quickly. 5 into this is what? 17. Okay, please do it. Okay, and tell the answer whether you are getting 0 or not. Determinant of 5, 3, 7, 4, 9, 10, and 9, 12. So this is 17. So whether you check?
Yes, sir, it is coming 0.
Okay. Okay, thank you, Paritosh. Okay. So if you got 0, then it is good. So there is one more method. Okay. So next, yeah, this is a practice problem. I told you already. You can try later. And then next topic is a very important topic: eigenvalues and eigenvectors. Okay. So remaining matrices is topics. All the topics are depending upon this section. Okay. So that's why this is most useful and powerful okay section. Sorry. So okay, now first I will define what is eigenvalue and eigenvector. So suppose A is a square matrix of order n. A equal to Aij be a square matrix of order n. Okay, if there exists a non-zero column vector x, okay, and a scalar lambda such that Ax is equal to lambda x. So this is a matrix. This is a column. This is a column vector, non-zero column vector. Then you are writing the product of these two is some scalar into the same non-zero vector. Okay. So here lambda is called eigenvalue of the matrix capital A, and X is called eigenvector corresponding to the eigenvalue lambda. Okay, how to find the characteristic equation for a 2 by 2 matrix? Okay, so suppose 2 by 2 matrix, the general form is what? A11, A12, A21, A22. So this is a general form of any 2 by 2 matrix. Okay, now I'm going to find the characteristic equation of this matrix. The characteristic equation is, you can find the characteristic equation using determinant of A minus lambda I equal to 0, where A is the given matrix, lambda is a scalar, okay, and I is the identity matrix, 2 by 2 identity matrix. If A is 2 by 2 matrix, then your I is also 2 by 2 identity matrix. If A is a 3 by 3 matrix, then your I is 3 by 3 identity matrix. Okay. So then determinant of A minus lambda I. What is determinant of A minus lambda I? Determinant of A. This is a matrix A minus lambda. Okay. I. You know, identity matrix is what? 1, 0, 0, 1. So now this is equal to 0. This implies the same matrix A is here minus multiply by lambda. So minus, okay, keep minus outside, lambda 0, 0, lambda. And then this is one matrix, this is one matrix. This is 2 by 2 matrix, this is 2 by 2 matrix. So if you subtract these two matrices, you will get what? A11 minus lambda, and then A12 minus 0. Next, A21 minus 0, and then here A22 minus lambda is equal to 0. So that is in the next step here. Okay. So okay. So A11 minus lambda, and then A12, A21, A22 minus lambda. And then determinant, you need to expand the determinant. Multiply these two minus multiply these two. So A11 minus lambda into A22 minus lambda minus A12 into A21. Okay. Now if you multiply these two, you'll get what? A11, A22 minus lambda into A11 minus lambda into A22 plus lambda square. Okay, if you multiply these two. So here it is written, in the next step, it is written lambda square, you can check it, lambda square. From these two, I took commonly what? Minus lambda, remaining is what? A11 plus A22, that is here. And then this is A11, okay, A22, and then the last term, minus A12 into A21 equal to 0. Okay. So now, lambda square, from here to here, lambda square, this is sum of the main diagonals. Okay, wow. This is what? Sum A11, A22 is what? You can see here. A11, A22 is sum of the main diagonal. Sum of the main diagonal is called trace of A. This is nothing but, I will write here, sum of the main diagonal elements of capital A. That is nothing but a trace of A. So lambda square minus trace of A into lambda But this is nothing but determinant of A. You can check it. A11, A12, A21, A22. So this is the matrix. If you take the determinant, you'll get what? A11, A22 minus A12, A21. You can check it here. Okay, A11, A22 minus A12, A21. So this expression is nothing but determinant of the matrix. So for any 2 by 2 matrix, the characteristic equation is of the form lambda square minus trace of A into lambda plus determinant of A. Okay. So next note. The note, I am going to give there is one more shortcut method to find the characteristic equation directly. Okay. So consider capital A equal to, this is the given matrix, 2 by 2 matrix. Characteristic equation of, we will write, that is what, determinant of A minus lambda I equal to 0, where lambda is a scalar. So from this, for any 2 by 2 matrix, the characteristic equation is the form lambda square minus S1 into lambda plus S2 equal to 0. What is S1? What is S2? S1 is nothing but A11 plus A22. A11 plus A22 is nothing but trace of A. Okay, that is the sum of the main diagonals. S2 is A11, A22 minus A12, A22. There is no need to write this directly. S2 is equal to determinant of A. That is okay. So this is the alternate method. Okay, but here I wrote everything. Okay, here wrote the matrix and then simplify everything. I got it here, but like this method also, you can write the characteristic equation of any 2 by 2 matrix. Similarly, for a 3 by 3 matrix, how to find the characteristic equation? Okay, suppose the general form of a 3 by 3 matrix is A equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. The characteristic equation of the matrix A is determinant of A minus lambda equal to 0, where lambda is scalar. Okay, so here A is a 3 by 3 matrix. Your characteristic equation is in polynomial 3. Okay, cubic equation. So in the previous case, A is a 2 by 2 matrix. That's why you got it's a quadratic equation in lambda. Okay, so in the previous case, what is the characteristic equation? Lambda square minus S1 into lambda plus S2 equal to 0. So S1 is what? Trace of A, and S2 is determinant of A. But here, lambda cube minus S1 into lambda square plus S2 into lambda minus S3 equal to 0. So plus minus, alternatively you have like this, where here also S1 is a trace of A, and S3 is a determinant of A. S2 is sum of the SVM, sum of the minus of main diagonal elements of A. Okay, so anybody got the definite? Anybody understand what is S2 implies? If you understand, you can tell me. Otherwise, I will explain in the problem. Okay, if you know, you can tell. Otherwise, I will explain when we solve the problem. Then you can get a clear idea. Okay, now yes, determinant of A minus lambda I equal to 0 is called characteristic equation of the matrix A. Okay, so roots of the characteristic equation A is called eigenvalues of A. So these are the note. So determinant of A minus lambda I is called characteristic equation of A. Roots of the characteristic equation of the matrix A is called eigenvalues of A. Eigenvectors of A are given by A minus lambda I into x is equal to 0, where x is non-zero vector. Okay, this is non-zero. And one more thing, you should know rule of cross multiplication. Suppose if you have two equations like this, okay, a1x plus b1y plus c1z equal to 0, a2x plus b2y plus c2z equal to 0. Okay, first you will start from coefficient of y. What is the coefficient of y? b1. What is the coefficient of z? c1. And then coefficient of x, a1, and then end with the coefficient of y, b1. Okay, and then similarly here, coefficient of y is b2, coefficient of z is c2, x is a2, coefficient of y is b2, and then you should write here x, y, z. Okay, so x divided by, you need to multiply these two, b1 c2 minus, okay, actually here it is written x is equal to, okay, so the both are same, okay, x b1 c2 minus c1 b2, similarly which is equal to here y, okay, y by c1 a2 minus c2 a1, which is equal to z divided by a1 b2 minus a2 b1 equal to some constant k. So I use, when I am finding the eigenvectors of the given matrix, this idea. Okay, so I think I explained here what is eigenvalue and eigenvectors first, and then I explained here how to find the characteristic equation of the 2 by 2 matrix, and then how to find the characteristic equation of a 3 by 3 matrix. Okay, and finally I gave some note. Okay, suppose if you have any doubts in this section, in this part, you can ask me, because now I am going to solve the problem. Okay, so I think if there is no doubt, means I think everyone understand the concept clearly. Okay, so now I am going to ask the question. First problem, find the eigenvalues and eigenvectors of the matrix capital A equal to pi 1 minus 1, 1 3 minus 1 minus 1 minus 1 3. Solution. Characteristic equation of A. A is the determinant of A minus lambda I equal to 0. So what is determinant of A minus lambda I? Please tell. US stream. Okay, Prashant.
Lambda cube minus.
You got the final answer,
No, sir, I am saying formula, sir.
Okay, okay. Direct, Prashant, first we will do by step-by-step method. Okay, and
Okay,
then,
sir.
okay, okay. So I am asking what is the matrix A minus lambda I?
Sir, can I tell?
5 minus
Sir, can you see?
5 minus lambda
5 minus lambda,
1 minus 1
1 minus 1, yes.
1
1,
3 minus lambda
3 minus lambda,
minus 1
minus 1,
minus 1 minus 1 3 minus lambda.
minus 1, minus 1, 3 minus lambda. Okay, thank you, Prashant. So this is the first, I am going by first method, okay, equal to 0. Now, I am
Sir.
going to, yeah.
So can you explain it how only the diagonal elements are getting the lambda, sir?
Uddhavan, actually, this is a matrix A minus lambda, yeah.
Yes, sir.
What is the matrix A?
Oh, 1 0 0. Sorry, sir.
Okay.
I got 1 1 1. That's sorry, sir.
Okay. So now you need to expand this determinant. 5 minus lambda, okay, into 3 minus lambda whole square. 3 minus lambda whole square minus 1 into leave this column, leave this row, 3 minus lambda plus 1, so minus 1, okay, minus 1 into leave this column, leave this row, multiply these two, minus 1 plus 3 minus lambda. So please check it carefully, which is equal to 0. So in the next step, 5 minus lambda. If we expand this, we'll get what? 9.
9 plus lambda square minus 6 lambda.
Yeah, minus 6 lambda. What is your name, Pa? Dhruva.
Sir, Vikash, sir.
Vikash. Okay. Okay. We multiply by minus 1, we'll get what? Minus 3.
Sir, you missed minus 1 before, sir.
Okay, thank you. Minus 1. So, and then here what? This is minus, okay, first I'll put minus 1 or minus, okay. This is 2 minus lambda. So here minus, this is what? 2 minus lambda equal to 0. Okay. Multiply these two and tell the, okay, still you have you can simplify. Okay, 5 minus lambda lambda square minus 6 lambda plus 8. Okay, here minus 2, so plus 4 plus lambda. So 2 lambda plus 2 lambda minus 4 plus 2 lambda minus 4 is equal to 0. Okay, now multiply, will get what? 5 lambda square minus 30 lambda minus plus 40 minus lambda cube plus 6 lambda square, okay, minus 8 lambda plus 2 lambda minus 4 equal to 0. Okay, so lambda cube, how many lambda cube? Minus lambda cube. Lambda square is
Plus 11 lambda square.
Yeah, plus 11 lambda square. Okay. How many?
Minus 36 lambda.
Minus 38 plus 2. Okay. Minus 36 lambda. Okay. And then constant 40 minus plus 36 constant. Or you can multiply throughout by minus 1. The characteristic equation is lambda cube minus 11 lambda square plus 36 lambda minus 36 is equal to 0. This is the first method. Okay, so I'll quickly tell the second method also. Okay, so I think Prashant told that the second method is what? Lambda cube will start from lambda cube minus S1 into what? Lambda square plus S2 into lambda minus S3 equal to 0. Okay, so eventually what is S1?
11, sir.
Yeah, that is first you should tell a trace of A. Okay, wow.
Okay, sir.
Yeah, trace of A. Trace of A is what?
11,
Trace,
sir.
yeah, 5 plus 3 plus 3, that 11. 5 plus 3 plus 3, that is equal to 11. Okay,
11.
yeah. And then S2.
Sum of the minus of the main diagonal.
Okay, correct. Okay, sum of the
Minus of the main diagonal.
yes, sum of the minus of main diagonal elements of A. Okay, so actually this is how to find this. Okay, so what is the matrix A? Quickly tell. 5
5,
5.
1, minus 1,
uh,
1, 3, minus 1,
uh,
minus 1, minus 1, 3.
yes. So first you should fix this diagonal element. Leave this column, leave this row. Remaining have a 2 by 2. What is a 2 by 2?
3, minus 1, minus 1, 3.
Yeah, 3 minus 1
Minus 1,
3.
3.
Okay. Similarly, plus fix this one. Leave this row, leave this column, leave this row. Remaining is what?
5, minus 1,
5 minus 1,
minus 1, 3.
minus 1, 3. And similarly, fix this one, leave this column, leave this row. Remaining 2 by 2 matrix.
5, 1, 1,
1,
3.
3. So now expand this. 9 minus 1,
9 minus 1, sir.
15 minus 1.
15 minus 1.
Okay.
15 minus 1.
15 minus 1. Okay. Plus 15 minus
1.
So 30, 39. 39 minus 3, 36.
36, sir.
So S2 is 36.
30.
Okay, what is S3? Determinant of A?
Determinant of A, sir.
Okay, so determinant of A is 5. Sorry,
1.
1.
Minus 1.
Minus 1, 1, 3.
1, 3 minus 1.
1, 3 minus 1. Okay.
Minus 1, minus 1, 3.
Okay. Now expand this determinant. Okay, if we expand this,
5
like
into
5 into 9 minus.
9 minus 1.
Okay, minus 1.
Minus of 15
3.
minus 1.
3 minus 1. Okay, minus 1 into.
Minus 1 into minus 1 plus 3.
Yes. So this is equal to
What are 34, sir?
34 hours. Correct check பண்ணுப்பா. This is what 8 40
Is a 40 minus 2 minus 2, sir.
minus 2.
36 is
Yeah, 36.
36, sir.
So this is 36. Now,
Yes, sir.
now substitute S1, S2, S3 value in this equation.
Lambda cube
Lambda cube
minus 11 lambda square
minus 11 lambda square. Okay.
plus 36 lambda
Plus 36 lambda.
minus 36 equal to 0.
Okay. Please check it whether both the answers are correct.
Yes, sir.
Okay.
Yes, sir.
So you can, the examination, you can use any method. Okay. That is up to you. You can decide. So I'll stop here. Okay. Just I finished only 20% of the problem. Remaining 80% of the problem, I will do tomorrow. Okay. Thank you.
okay, sir.
Okay.
Thank you.
Thank you, everyone.